Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ritika, welcoming you to part 2 of lesson 1-3, vectors and dot products, especially for my grade 11 elite math students. It's a must-watch video covering two important and complex topics. Number one topic is the projection of one vector onto other, and number two topic that we'll be covering today would be solving real-world problems on work. Okay, so that's a physics concept of work, but we are going to see how projection of one vector onto other and how the dot product helps us to find and solve the real world problems on work. So let's dive into the video, a must watch video. Do watch it till the end. And as always, you will have important textbook problems towards the end of this session. So stay glued to the channel and let's start today's video. Okay, so the concept that is our key concept for today is projection of vectors and projection of one vector onto other vectors. So there are two vectors that are given to you, vector u, vector v, and you are trying to project vector u onto v. So when I say you are trying to project, it's in simple words like a shadow of one vector on the other vector. So if I draw two vectors here, one vector is vector u, one vector is vector v. So for example, this is another vector v. Then these are two vectors and I'm trying to project this vector u onto this v. So as you can see, the shadow would come around about the horizontal somewhere like this, and then because you are taking a shadow, you have to drop a perpendicular. So I'm going to drop a perpendicular. This is 90 degrees. Okay, and this angle, let's take it to be theta. Then the two vectors u and v, we are trying to calculate the projection of vector u onto v. How do you write? Projection of vector u onto v. So in below you will write the second vector, above will be the first vector. So this vector I'm denoting by another vector, say w1. So I'm taking a vector w1 which is parallel to vector v. Just look carefully how I'm doing. So this vector w1 I'm taking as the projection vector, and this vector is parallel to vector v1. So w1 is parallel to v. These two are parallel vectors. And then because of this 90 degree, I will take another vector w2 which is orthogonal to w1. So w1 plus w2. These are the two vectors you are going to project, and w1 is the one which is parallel to v and w2 is the one which is perpendicular. So w1 and w2 together are orthogonal vectors. Very, very important. So now I hope you've understood that figure. So that leads to this one. So let u and v be non-zero vectors. In the exam, you will get one question where first you calculate the projection. So you will use this formula. You will take vector w1, w2 as the components of u such that w1 is parallel to v. As we saw, w1 is parallel to v in the same direction, and w2 is perpendicular to v. So this w1 is the projection of vector u onto v, which is equal to, now let's look into the formula, u dot v, take in the numerator the dot product, divide by the absolute value square and multiply whole thing by v onto v. So denoted by this projection. This is your important key concept. Let me just do a simple problem to explain you how the formula works. So the formula is projection of u onto v, that's how you write, which is equal to u dot v in the numerator divided by magnitude square of vector v and whole thing multiplied with vector v. Okay, so v is given the vector. Let's find its magnitude. The magnitude of vector v and its whole square would be equal to 5 square plus minus 5 square. So how much is that? 25 plus 25 or square root of 50. Now this was the magnitude, and now you had a square. So this whole square means the square of this. So the square root will cancel out and the square of this would give you 50. So absolute value of v square or its magnitude. This denominator you have got as 50. Okay. What is vector v? Already given to you, 5 comma minus 5. I'm now just doing substitution. And now we need in the numerator u dot v, means this multiplied with this. I hope you have not forgotten from the previous video, part 1, how we do that. So 3 comma 2 dot product 5 comma minus 5. So x with x, y with y. So it will be 3 multiplied with 5 plus 2 multiplied with minus 5. Let's simplify. So this is 15 minus 10, 5 over 50 times 5 comma minus 5. Divide by 10, you cancel this out. So this is 1 over 10 times 5 comma minus 5. Cancel and simplify. So 1 by 2 comma minus 1 by 2. So this is how you calculate projection. So your final answer, projection of u onto v. Let me write projection of u onto v is the vector 1 by 2 comma minus 1 by 2. So that's your final answer. Let's put it in a box. That's how you calculate projection. Now, extending the concept of projection of vector u onto v, we have the component, we have the definition of vector component. So, in your ministry exam, the kind of question that you will get, you have to also find w1 and w2. What is that? So, if u and v are non-zero vectors, then u can be written as w1 plus w2. You saw in the previous slide that w1 is parallel to V and W2 is perpendicular to W1. These are orthogonal vectors. So you have to resolve, you have to write U as the sum of two orthogonal vectors. I'm writing here U is the sum of two orthogonal vectors. I hope you remember about orthogonal vectors from part 1. If you've forgotten, do visit that. And in simple words, it means W1 and W2 are perpendicular to each other and that their dot product is 0. Then, if you find your W1 using the projection formula, this is the one you saw in the last slide, then W2 would be just here U minus W1. So U will be given to you, W1 you will calculate, subtract them and get W2. So in your ministry exam, the question will come like this. Write U as the sum of two orthogonal vectors, one of which is the projection of U onto V. So let's see a question and solve it together. Okay, so here we are learning how to decompose a vector using vector components. So in the question, you will be given the two vectors u and v. You have to break down u as sum of two vectors w1 and w2 which are orthogonal, where w1 is the projection that you already learned. So the next step here would be to calculate this projection, to calculate W1. So put in the values. We take the dot product. So 3 goes with 6 minus 5 goes with 2. So the numerator of the dot product gives you 8. In the denominator, you calculate vector V whole square, which is 6 square plus 2 square. So this is 36 plus 4, which is 40. So that's why you put here 40. 6 comma 2 from the question, cancel the common terms and simplify. So your W1 vector comes out to be this. Now we need to find W2. So once you have your W1 here, W2 from this formula, number 1, would be u minus w1. How much is u? This vector. How much is w1? This vector. So just subtract. So 3 minus 6 by 5 for the x component minus 5 minus of 2 by 5 y component. So this is what you get, and therefore you have written u, you have decomposed u as the sum of two vectors w1 and w2, where W1 is the projection of the vector u onto v and W2 is orthogonal to W1. That completes the question. Okay, so I hope you've understood the concept of projection and how we can write U as the sum of two orthogonal vectors. Time to take an important textbook problem from your math book, page 25. Let's do and solve it. So vector U is given as 1, comma 2. Vector V is given as 8, comma 5. So you need to first find W1, which is projection of vector U onto V. What is the formula? U dot V over absolute value, the magnitude whole square multiplied by V. So let's calculate U dot V first. Okay, this is U, this is V. X goes with X, Y goes with Y. So 1 with 8 plus 2 with 5. So this is 8 plus 10 or 18. Okay, so we are done with U dot V. Let's find magnitude. Magnitude of V square would be the square root whole square of 8 square plus 5 square. So this is 64 plus 25, which is 100. Okay, so you have value of V, and now let's put it everything into this formula for W1. So W1 is, oh, we have done a wrong calculation here. Let's correct it. So 64 plus this is going to give you 89. Okay, now W1 is U dot V, which is 18 over 89 times V, which is 8 comma 5. Let's simplify it a little bit to do the multiplication. So this comes out to be 144 over 89 comma 90 over 89. So you are correct. That's the projection. So W1, which is the projection of U onto V, is done. Now we need W2. This is done. So W2 is U minus W1, which is equal to U is this, W1 is this. Let's just subtract them. So 1 minus 144 over 89, comma 2 minus 90 over 89. So let's do some calculation. Simplify, and this comes out to be minus 155 over 89, comma 88 over 89. So you've got your W2, you've got your W1, and you've written U as W1 plus W2. So you can also check your answer. It's given here in pink. So our calculations are correct. So this is how you find the projection of vector U onto V and then write U as the sum of two orthogonal vectors. Very, very important question. One ministry question will surely come from projection topic. Moving on, let's go on to the second learning objective for today, which is an important application of the dot product, which is work. So let me read out a problem for you to make it easy to understand how work is an application and how can you find the value of work or calculate work using dot product. So the horse pulls 1,000 feet with a force of 250 lbs at an angle of 37 with the ground, as you can see in the picture. So the angle here is given to you very clearly as 37 with the horizontal, and the horse is pulling it with a force of 250 lbs at this angle. The amount of work done is 4 times displacement. You all know that this is the formula for work. Work is a scalar quantity, so it is equal to force with dot product of displacement. So how do we calculate this displacement? It is equal to the magnitude of the force multiplied with magnitude of the displacement along with the cosine of the angle between them. So if you see this force, I'm just drawing a rough diagram here. This force, which is actually 250, is making an angle with the horizontal of 37. So if you break this force along the horizontal component horizontally, then it will be F cos 37, right? The angle is given to you. So the horizontal component is what we need for the force, because that's what is making 37 degrees. So that's why you have absolute value of force multiplied with absolute value of displacement with cosine of the angle, because cosine trigonometric ratio, if you remember SOHCAHTOA, so is related to the horizontal. That's why we are taking the cos of the angle. So that's how dot product is an important concept that you need to understand in order to find work, in order to calculate work and solve word problems. And you can also use the concept of projection if an angle is given. What does that mean? Let's see. So as you know by the definition of work, that work is force dot product distance or dot product displacement. Now, if the force is constant and not at any angle, then you can directly find the dot product by multiplying the force with the distance or the displacement like this. This formula will work for you, number one. However, if you have something like the previous slide where the horse was pulling at an angle, that means the force was at an angle. In that case, you can use the concept of projection to find the work. So the formula will change in this manner, that work done when the force is at an angle is equal to the magnitude of the projection of the force along the vector PF, or the displacement, multiplied with the displacement. So second formula will apply. Okay, so before I show you the question that we'll be solving from your math book, let's do a real world solved example where you calculate work. So let me read out the board problem loud and clear for you, and we are going to highlight the important information as always. A person pushes a car with a constant force of 120 newtons at a constant angle of 45 degrees as shown. Find the work done in joules moving the car by 10 meters. Okay, so you look at the figure first. There's a person here moving the car. So the force is applied here, and the force is applied at a constant angle of 45 degrees. So how much is the force? The force is given to you 120 newtons. What is the angle? It is given to you 45 degrees. And then the car is moving 10 meters. So if you see carefully, the car is moving along the horizontal, only the horizontal, so there's no vertical component. So if you want to write this vector, it will be 10 comma 0. I hope this is clear to you, because always we write x comma y. This is the form of vector where x is horizontal component, y is vertical component. So there is no vertical component. The car is only moving on the road, so it is only having horizontal. That's why the vector is 10 comma 0. Very important point. Now this force of 120 newtons, when you take the projection on the horizontal axis, then it will come like this. The projection of the force along AB, right? So this is how you write the projection. Now this projection, again from the figure you can see, this is the force, this is the angle 45, so it is applied in the horizontal direction. Okay, that means this projection can be calculated, or this horizontal component can be calculated by taking the force along the cos of the angle. So 120 cos 45, that will be the value of the projection. I hope this point is clear. Because we are just taking horizontally, there's no vertical component, so the projection would have this value. Now you are going to multiply the projection. The same thing is written here. Use the projection formula for work. The magnitude of the projection of F onto AB is F cos theta, so it is this value, and the magnitude of the directed distance AB is 10. You already know this vector, so it will directly be multiplied with 10. You can use your calculator, do the substitution, put the value of cos 45, and this will come out to be 848.5 joules. Okay, the unit will be joules because you have to give the work done in joules. Okay, there's another method. The first method used projection formula. The second method used the dot product. So you can also take the vector dot product. So if you take the first vector as the force, look here carefully, then its component would be 120 cos 45, 120 sine 45. Now if you look carefully, the angle is clockwise. So when the angle is clockwise, I'm going to change the color here. When the angle is clockwise, the angle is negative. That's why cos will be minus 145, sine will be minus 145. Now you all know cos is an even quantity. Cos of a negative angle also gives positive result. However, sine of a negative angle gives negative result. And here the second vector we've already got as 10 comma 0. So when you take dot product of f with AB, you take dot product of 120 cos minus 145 with 10 and 120 sine minus 145 with 0. So the one with 0 is khalas. So you're only left with 120 cos minus 145 multiplied with 10, which is the same result. So either you do method 1 or method 2. Don't do both. Anyone which you find easy, both will give you same answer. So here also 848.5 joules of work is done in pushing the car. Let's do another question. Personally, out of the two methods you saw, I like more the method of dot product. So I'm going to be using that method here. So let's do the reading of the word problem, highlight the important information, and then solve similarly. So Faris is pushing a vacuum cleaner with a force of 375 newtons. The handle of the vacuum cleaner makes a 60-degree angle with the floor. How much work in Newton meters does he do if he pushes the vacuum cleaner 2 meters? Now you can very well understand here also the vacuum cleaner is going to go on the floor. So there is horizontal component but no vertical component. So 2 comma 0 would be one vector. For the second vector, the force is given how much? Let's write force is given 375 newtons, angle is given 60 degrees. So let's calculate the components. Now the angle here which is made is with the handle of the vacuum cleaner. This is handle, this is the floor. So if you see the angle is again clockwise, so we will take negative value. So the 375 cos minus 60 and 375 sine minus 60. These will be the components of the first vector. So this is like vector u, this is like vector v. We need u dot v, okay, because we are calculating work done, and work done is the dot product of force with displacement. What is the displacement? This one. How much displacement? 2 meters. What is the force? 375 cos minus this and this. So you can calculate, plug in the value, 375 cos minus this. I'm just now substituting in the dot product, and when you take dot product, I hope you remember from video 1, x goes with x, y goes with y. Now this going with 0 will remove, so you are only left with 2 times multiply 375 and cos 60 degrees. Okay, now do the simplification. How much is cos 60 degrees? It is 1 by 2, so 1 by 2 and 1 by 2 is khalas, and you are only left with 375 newtons. That is the correct answer. So the work done in this case by moving the vacuum 2 meters is 375 newton meter or 375 joules. So that brings us to the end of today's session. It was a very important session. I hope you reached to this part of the video where you have watched the whole video and have understood the concepts of projection, how the dot product is used for work, and how you can write a given vector as the sum of two orthogonal vectors, one of which is a projection of u onto v. A very important video on vectors here comes to an end. I hope you found the video useful, and if you did, please give it a thumbs up. Subscribe to the channel for more such videos, and coming up next would be the next lesson on vectors. So stay glued to the channel and press the bell icon so that you don't miss any upcoming videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.